In this video, we are going to walk through a Pulley problem in physics in which we find the acceleration in a given system and the tension in the rope of two blocks that are connected by a pulley. So let's go ahead and just jump right into this example. This says a 3.3 kilogram box sits on a horizontal frictionless surface and is connected to a rope that wraps over a frictionless pulley to a second block with a mass of 2.1 kilograms. Determine the acceleration in the system and the tension in the rope. So I've gone ahead and sketched out this situation here. We have this first block, which is 3.3 kilograms in mass, and it's connected by a rope and a pulley to a second block that's hanging over this edge, and this second block has a mass of 2.1 kilograms. Our question is, what is the acceleration in the system and what's the tension in the rope? So to solve this type of problem, we have to recognize that there's going to be a force in the x direction as this block starts to fall and as this block moves to the right. And there's also going to be a force in the y direction. So we're going to find those forces individually and we'll be able to solve this problem. So let's start with the x direction. We can say the net force in the x direction. So Newton's second law of motion says that the net force of some object is equal to the mass times the acceleration. So in this case, the mass will be 3.3 kilograms. So for this sake, let's call this block mass 1. We'll say this block has a mass 2. So for this particular force in the x direction, we'll say m1, mass times acceleration, and we'll say acceleration in the x direction. Now, because we're talking about a mass that's connected to a rope, we can also call this force, instead of the net force in the x direction, we can call it the tension force. So we'll say T is equal to m1 times the acceleration in the x direction. So this is our first crucial equation that we're going to use to solve this problem. Now, we said we also need to figure out what is the force in the y direction. So what we can say is the net force in the y direction. In this case, there's going to be two forces acting on this block. The first is the force of gravity, which is simply mass times gravity. So that will be m2 times g. But then we're also going to have a tension force that's opposing this force. So it's going in the opposite direction. So really, our net force in the y direction, to find that, we have to add these two forces together. So we'll say it's equal to T, the tension force, and then notice that this force is headed in the negative direction. It's heading down. So we'll say minus m2 times gravity. Now, one thing that we want to do when we're solving these problems is we always want to replace net force with ma. So again, Newton's second law says the net force is equal to the mass times the acceleration of an object. So really, instead of writing the net force in the y direction, we can say m, in this case m2, times the acceleration in the y direction. And that will be equal to, again, we have T minus m2 times g. Now, one other important thing is that this net force in the y direction, it's going to be headed in a negative direction. So this whole left-hand side, this needs to be negative. Now what we can do is we can rewrite this equation in terms of T. So if we just move this m2g to the left-hand side, here's what we get. We'll write T is equal to m2g, so a positive, minus m2 times the acceleration of y. And this is going to be our second crucial equation that we need to solve this problem. So we have just done the hardest work of this entire problem, finding these two equations. Once we have found these two equations, it becomes very easy to find both the acceleration and the tension in the rope. So what we're going to do is notice that both of these equations say that T is equal to some value. So all we're going to do is just set these two equations equal to each other, and we can solve for acceleration. So I'm going to clear a little bit of space here. Okay, so I've rewritten those two equations that we found. We're just going to set these two equations equal to each other and solve for A. So here's what we can say. m1 times acceleration in the x direction is equal to, we have m2g minus m2 times acceleration in the y direction. Now, one important insight that we need to have is that the acceleration in the x direction and the acceleration in the y direction, these two values must be equal. Because again, these two blocks are connected by a rope. So they are going to have the same acceleration as they're moving. So really, instead of writing a sub x and a sub y, we can just write a because they're going to be equal. So let's go ahead and just make this a, and we'll make this a sub y, we'll make this a as well. Okay, so now what we can do is we know all of these values except for a, so we're going to solve for a. So m1, that's the first mass, that's 3.3, so we get 3.3a is equal to m2, that's 2.1, times gravity. The magnitude of gravity is 9.8. And then we have minus m2, so m2 again is 2.1 times a. So if we move this 2.1a to this left-hand side, we'll get 5.4a, so we're adding 2.1 and 3.3, is equal to 2.1 times 9.8. That turns out to be 20.58. And lastly, to solve for a, we'll just divide both sides by 5.4. So these cancel out. We'll be left with a is equal to 20.58 divided by 5.4. That turns out to be about 3.81. And we're talking about acceleration, so we'll say meters per second squared. So we just found the acceleration in the system. And lastly, we want to know what is the tension in the rope. So what we can do is we can take this value for a, and we can plug it into either one of these equations to solve for t, the tension. So it looks like this equation obviously would be a little bit easier to solve. So let's use that equation. So we'll get the tension is equal to m1, so the mass of the first block, that's 3.3, times a. A we just found is 3.81. So when you do 3.3 times 3.81, that comes out to about 12.57. And we're talking about tension, that's a force. So we'll say newtons as our units. So that will be the tension in the rope. So that's how you can solve that type of pulley problem. You just need to find the force in the x direction and the force in the y direction, and then write both of those equations in terms of t, the tension. And then once you have those two equations, it becomes very straightforward to solve for both the acceleration and the tension.